So today we will discuss what is meant by terminal velocity of a body falling in a viscous medium. So whenever a body starts falling in a viscous medium, the three forces are acting on the body. Number one is the force of gravity, that is equal to the weight of the body, and second is the buoyant force, which is equal to volume of body multiplied by density of the fluid into g, and the third is the viscous force. This is 6 pi eta rv. So these two forces are acting in the upward direction and force of gravity is acting in the downward direction. Initially the force of gravity is higher than the sum of these two forces. That is why the body is accelerating. That means its velocity is increasing in the downward direction. Okay, but as the velocity increases, this viscous force also starts increasing because this viscous force is directly proportional to velocity. So it will increase initially. Okay, this is the velocity of the body falling in the viscous medium and this is the time. Okay, so initially up to certain time this velocity will increase. Okay, and after some period this velocity will become constant. That means the acceleration on the body will become zero. This will happen when the downward force of gravity becomes equal to the summation of these two forces which are acting upwards. So at this condition, this velocity of the body is called terminal velocity. That is, this velocity is called Vt. That is terminal velocity. So now we will derive the formula for this. So we can say that the volume of the body is V. That is nothing but 4 upon 3 pi r cube, because this is a spherical body, into rho, that is the density of the body material, into g. This is the weight of the body. Okay, or it is the downward force. So this will become equal to the summation of these two forces. So drag force, this is buoyant force, is nothing but V into sigma g. So this will be 4 upon 3 pi r cube into sigma g plus this viscous force, that is 6 pi eta r. Now V will be equal to Vt, because this at terminal velocity these two forces become equal. That is downward force due to gravity becomes equal to the upward force, that is total upward force. So with this we can say that 6 pi eta r Vt will be nothing but this will be 4 upon 3 pi r cube into this will be rho minus sigma into g. So Vt will be equal to this 6, this 2 2 are 4, 2 3 are 6. So this will become 2 upon 9. This pi will get cancelled out. This will become r square rho minus sigma g divided by eta. Because this r will, this square, it will become square. Okay, r will cancel out. So this is the formula for terminal velocity. So we see that the terminal velocity Vt is directly proportional to r square. That is the square of the radius of the spherical body. And when this sigma is negligible, say in case of air, then this terminal velocity Vt, then we can neglect sigma as compared to rho. So this will become 2 upon 9 r square rho g upon eta. This is when air is the medium in which the ball is falling, or say the raindrop is falling in air. So the density of air is negligible as compared to the density of water in case of raindrops. So this terminal velocity becomes this. Thank you and wish you all the best.